Okay, today we're going to start with our final type of a reaction. So this is the fifth one, combination reactions. So our learning target once again is to classify the types of chemical reactions. Our success criteria: to balance a chemical equation, to describe/identify a combustion reaction, to predict a combustion reaction. Now, with the combustion reaction, it is a rapid chemical combination of a substance with oxygen. Now, we're going to deal with it as the fuel being oxygen. That's not always necessarily the case, okay? But as far as we are going to deal with combustion, it is going to be dealing with oxygen as the fuel. Excuse me. Once again, it's the rapid chemical combination of a substance with oxygen that involves the production of heat and light. Chemists recognize several fuels capable of acting as oxidants for this combustion. As I said, oxygen's the one we're going to be dealing with. Chlorine, fluorine, nitrous oxide, nitric acid, chlorine tetrafluoride are just some more of these particular fuels for combustion. Now, when we have a combustion reaction, we are dealing with a hydrocarbon and oxygen. So what's a hydrocarbon? Well, it's carbon and hydrogen. Carbon and hydrogen. Sometimes we mix in oxygen into that hydrocarbon as well. And our products are always going to be carbon dioxide and water. So a hydrocarbon and oxygen will yield carbon dioxide and water. Here's our very first one, so go ahead and copy this into your notes. Heptane. Heptane, if we break this down, okay? Hept, any idea what hept is? Okay. Ethan, what is it? 7, okay? Hept is our prefix for 7. When we did our molecular model kits where we were building different chemical or different compounds, okay? A and E told us that those were all single bonds. So heptane tells us that I have 7 carbons right here, and it is all single bonded together. Just a little bit of hydrocarbon learning here. Now, as I said before, we have a hydrocarbon, we have oxygen, and that's going to give us carbon dioxide and water. So our two products are always going to be carbon dioxide and water. Now, when I'm dealing with one of these combination reactions, and we're going to call this a combination number 1. I wouldn't just put C because somebody could, or actually this is combustion. Somebody could, if you just put C, somebody could think it was a combination reaction. So I would put the COMB for combustion number 1, and we only have one combustion, so it's going to be pretty easy when you find that. Now, as I'm balancing this combustion reaction, because that's all that this is, you just have to balance it. I'm always going to start with my carbon. So I can see that I have 7 carbons right here. So I'm going to put a 7 in front of my carbon right there. I'm going to save my oxygen for last because oxygen is by itself. So the next thing I'm going to balance is my 16 hydrogen right here. So if I put an 8 right here, 8 times 2 is 16. I have my 16 hydrogens. That leaves me with just figuring out how many oxygens I need. Now, I can see right here that I have O2. So I don't have any oxygens over here. So I know that these oxygens on my product side need to be an even number because I can never make O2 odd. So 7 times 2 is 14 plus 8. 14 plus 8 is what? 22? So I have 22 oxygens on my product side. So on my reaction side, I'm going to need 22 also. So I'm going to put 11 in front of there. I'm going to clean up my equation. And I have balanced this first combustion reaction. Any questions? All right. Here's our second one. Pentanol. Pentanol is our second one, just to give you some hydrocarbons. Pent tells us 5, right? Pent tells us that we're dealing with 5. The OL here tells us that we have an alcohol, okay? And all an alcohol means is there is a hydroxide group bonded in with the pentane. Okay, that OL tells us that there's an alcohol. So, as you can see, we've got a little added O in there. An added O in there that sometimes presents a little bit of a challenge. So we're going to go with our carbon dioxide and our water. Okay. Once again, I am going to start out with balancing my carbons. So I'm going to put a 5 right there. As I put a 5 right there, I look at my hydrogens, and I have 11 plus 1, right? I have 11 right here plus this one, so that gives me 12. So I'm going to put a 6 right here to give me 12. Now here comes my problem. Can you see my problem yet? Can you see the problem yet? If I go 10 and I go 6, that's 16 oxygen. I've got that 1 oxygen right there that's not going to allow me to have that being even. So that's not going to work. What I just tried is not going to work, so I'm going to have to go back to the drawing board. So that 6 and that 5 is not going to work there. So where I'm going to start is I'm going to make sure that that oxygen right there is going to be an even number. And I've done so by making that, putting that 2 in front there. Now, once again, I'm going to start my carbons. 2 and 5 is 10. So I have 10 carbons on each side. I'm going to go back to my hydrogens. 11 and 1 is 12. 12 times 2 is 24. So I'm going to put a 12 there to give me 24 hydrogens. Now on my product side, 10 times 2 is 20. 12 times 1 is 12. So I have 32 total. Well, right here is 2. So that tells me that I need another 30. So I'm going to put a 15 right here. Now, right now, I'm going to clean it up a little bit and get these numbers out of the way. I'm going to clean it up. I'm going to go back right now, and it's important when you're doing this. I'm going to go back right now and check all my numbers out front. And I'm going to make sure that I can't reduce them. Can I reduce these? What do you think? Can I reduce any of those? Not with that 15 in there, I can't. Okay? So, this is a balanced chemical equation. Here's our next one. Once again, I see that OL. I see that OL and I say, oh, I've got ethanol. That OL tells me that I have that OH group, which is right there. F tells me that I have 2. Now, this is a little different because in our prefixes with our nomenclature, we had 2 as being what? Di? Okay, so this is a little different when we're talking about hydrocarbons. Okay, F is going to be 2. But nonetheless, once again, I have my carbon dioxide and I have my water. Once again here, I'm going to start out with my carbon. So I'm going to put a 2 right there to balance out my carbon. I have 5 and 1 is 6 hydrogen. 6 hydrogen. And that leaves me with my oxygens. 2 times 2 is 4. 3 times 1 is 3. So I have 7 total oxygens. Well, since I have that odd one over here with that hydroxide, I should be okay. Because I'm going to put a 3 right here. That's going to give me 6 plus 1 is going to give me 7. So I'm saying right now that I have a balanced chemical equation. If I get all that gook out of there. 2 carbons, 2 carbons. 5 and 1 is 6. 3 and 2 is 6. 3 and 2 is 6, plus 1 is 7. 2 and 2 is 4, plus 3 is 7. So I have a balanced combustion reaction. Final one we're going to work today is benzene. Benzene. If you remember, benzene was that ring that we made that had alternating double bonds. Okay? When we drew it out, looks something like this. Okay? That's our benzene ring. And then we would have hydrogens off of every one of these. So there's our 6 hydrogens to go with that benzene right there. So there's our benzene ring. Once again, our combustion reaction is going to give us carbon dioxide. It's going to give us oxygen. I haven't been putting this, so let's make sure we do this. We note that it's a combustion number 1, because that's the only combustion that we have. Once again, we're going to just start out by balancing our carbons. So I got 6 carbons there. I got 6 carbons on my reactant side. Now, oops, we got something wrong. I don't have O2 here. H2O, my bad. So now I'm going to balance out my hydrogens. It's going to give me a 3 there. And I can already see a problem. Can anybody else see a problem? Odd oxygens, right? That 3 times 1 right there is going to always give me an odd number of oxygens. I can't have an odd number of oxygens. So, I've got to go back to the drawing board. I've got to get rid of those. Those are not working. So what I'm going to do is I'm going to double my benzene. So when I double that benzene, that gives me 12 carbons. So I'm going to put a 12 right there for the 12 carbons. 6 times 2 is 12 hydrogens. So I'm going to put a 6 there. That's good, because I can now see that I have an even amount of oxygens. 12 times 2 is 24. 6 times 1 is 6. So I have 30 oxygens. So if I come over here, put a 15 there, I have 30 oxygens. And once again, I go through and check. 6, 12, 15, 2. Can I reduce? I cannot. I cannot. So when I clean this all up, get that little blue out from under there, get my benzene I drew out of the way, and look at that. Right there, ladies and gentlemen, is my balanced chemical equation for benzene, the combustion of benzene.